Hello everyone, welcome to today's session. In this session, we are going to discuss about the truss. About the introduction, we are going to talk about. First of all, I am Ramesh, working as an assistant professor in the Department of Aerospace Engineering. This subject goes to second year, and this is the first unit and first topic, introduction to truss. Let's see one by one. First of all, we should know what is a truss. A truss is nothing but is a structure, and it contains number of members, and they are joined firmly together by means of welding or riveting. And the members are very slender, and their ends are pin jointed. Generally, these uh, truss are arranged in a triangular unit so that it gives stability for the truss, and the loads are assumed only acting at the joints only. The truss members only carry axial forces. That means axial means tensile force or compressive forces. Bending moments and shear forces in the members are neglected, so that it gives the simplification is very easy to find the or analyze the truss. The member forces are available in the truss can be easily solved by using different methodology. Then we should know the types of trusses. Types of trusses based on different category are available. One is based on geometry, then based on uh, complexity, as well as based on the simple stress or plain stress or 2D construction. Like that we are having here the based on the geometry we are having plane truss as well as the space truss. Plane truss is the two-dimensional one. That means all members lie in a single plane. So, common in roof and bridge structures are coming under the plane trusses. Space trusses are called 3D trusses, which is very complex, and the loads are acting in the multiple planes. Especially the 3D trusses are used in the towers, aerospace structures, as well as the space frames. In aerospace structures, especially fuselage having the truss type structure. And one thing is another one is based on the stability. Based on stability, whether the truss is perfect or imperfect. How to find the truss as a perfect truss or imperfect truss? So there is a mathematical uh, expression is there. If m is equal to 2j minus 3, let's have m is equal to 2j minus 3. M is the number of members, j is the number of joints. If these left hand side and the right hand side both are equal, the conditions are satisfied, then the truss is called perfect truss. If it is imperfect means it should not be equal. That means m is less than 2j minus 3 or greater than 2j minus 3. If m less than 2j minus 3 means the number of members are insufficient. So that means the deficiency occurs. That is deficient truss. If number of members are higher than the 2j minus 3, the calculation if r is the numbers, then m greater than 2j minus 3, the type of truss is called redundant. Redundant means surplus or extra, excess. So there is the thing here given statically determinate truss. Already we studied about the statically determinate and indeterminate beams earlier. It is nothing but the number of reactions can be found in a beam by using only statically equilibrium equations. That is called statically determinate beam. And indeterminate means we cannot fully solve the beam problem to solve for reaction. That means number of equations are not necessary. That means not sufficient. We need extra equations. That kind of beams are called statically indeterminate beam. Here we are dealt with the trusses. So the condition for plane truss is equal to m plus r is equal to 2j. That means what I told you earlier, m is equal to 2j minus 3. Here the 3 is taken as the reaction. That means more than 2 they are taking. So here m is equal to number of members J refers the number of joints, R refers the number of reactions. So this is the basic equation to find whether the truss is perfect or imperfect. Finally, what is the difference between the frame and the truss? Frame is also a truss kind of structure only, but a truss and frame. The difference is if a frame when you are taking into there is no load, the external loads are acting on the structure. If external loads are acting on the structure, then it is that frame is called as the trusses. And external loads always acting on the joint only. External loads are acting only at the joints, not intermediate points. But in frame, no external loads are acting on. Here, a clear picture on frame versus truss is given, as well as joint type. For truss, it is pin joint, but a frame, it is not a pin joint one, it is a rigid or a semi-rigid one. And loads are acting only at the joints in the truss, but in frame, at joint and members. At joints as well as the members, in members, the loads can be applied. And member forces in the truss are only axial force. That means tensile or compressing compression. But in frame, both the axial as well as the bending and shear, all the forces will occur because in between member the load can act around, so bending will happen as well as the shearing effect will come into picture. But based on the geometry, what about the geometry in truss? Triangle type of units will be taken into account for stability purpose. But for frame, not a triangle shape, rectangular or any arbitrary we can take. Rectangle shape or any arbitrary shape, a frame can be framed. But for analysis point of view, truss analysis is very simpler, but frame is more complex because the load application. So that the effect axial, that is the tension, compression, bending, shear, or put together, all the effects will come into picture. So analysis is somewhat more complex when compared to the truss analysis. For example, for truss, bridges, roofs, we can say number of types of trusses. As an example here, for frame, we can have a building frame, machine frame, as well as automobile parts, also automobile frames we are also having. And we are being in a final topic, it's application of trusses. So trusses, yeah, widely the it plays a vital role in the applications, especially bridges, say railway, highway bridges, and roof systems like industrial shields, auditoriums, electrical transmission towers. We can see in the transformers, as well as cranes also. The number of the triangle element will come into picture there. No? As well as aerospace structures, aircraft frames, as well as space stations, and fuselage takes number of the truss type structures. Finally, the temporary structures, that is only the exhibition halls it can be used here. So once again, I will just summarize here. What we have studied is nothing but what is a truss, what is a frame, how can we define it? How a truss can be differentiated with the frame. How can we differentiate? Then we can have a two types of trusses: perfect truss as well as the imperfect. Perfect means that mathematical relation m is equal to 2j minus 3. If m less than 2j minus 3 or greater than 2j minus 3, they are coming under imperfect truss. One is called deficient, another one is called redundant truss. Then we can have a so many differentiation with respect to frame as well as the truss, load application, and analysis part of view, what type of joint or supports being acted on truss as well as the frame. Finally, we have concluded with the applications of trusses, especially bridges. We know roof, open auditorium. We can see that truss type structures, electrical transmission towers, cranes. So these are the very important real-time trusses applications of trusses we have seen each and every day. Okay, we will have another topic with different aspects in the aerospace structures in another class. Thank you all.